Good afternoon, chemists. Welcome to week 15. So exciting. This first semester is flying by. I can't believe we're at week 15, and I cannot believe that next week starts our winter break. So this past weekend, with the bitter cold settling in, my family and I were like busy with some housework that had got put off due to other things going on. And so it made me really think about like what is your favorite chore to do around the house? Like for me, I really like to put music on and vacuum. I think it's a pretty fun thing to get a dance going on while you're vacuuming. So it made me curious as to what you guys like to do. What is your favorite chore to do around the house when you are asked to do them, or maybe ones that you just do because you are decent human beings and like to help take care of your space? Doing dishes. So my 2-year-old loves to do the dishes. I don't really say that he does the dishes, more like plays with the water. Yes, he tries very hard to do the dishes, but it doesn't really work out for us. But that's okay. Oh, finishing dinner. There you go. Cooking can be very relaxing. My daughters, when they are a little bit stressed, one thing they do like to do is bake. Very cool. Yes, organizing is nice. Yes, I can, and also you can put music on when you organize. Oh, very good. All right. So, as you guys alluded to, we were saying happy holidays, Merry Christmas in our chats, and we are going to have a very long week because this week actually ends next week, Tuesday, the 22nd of December. So, just like in November with Thanksgiving, that week went long, this week goes long. So, you have until Tuesday, the 22nd, to get your work done. And then winter break begins on Wednesday, the 23rd. So 1 week from today through January 3rd. January 4th then is a Monday, and we will be back at school preparing to end our semester. So it's the end of the semester is ever so slightly started creeping up on us, and now it is hurling towards us. But we can all take a little bit of a break, hopefully, and enjoy some of that holiday spirit with friends and family, whether it's together or virtually. And so, just so you are aware that this goes until then. But because this is a long week, that means there is no e session next week. One, because their e session is next week is still considered week 15, and third or second is that we are in winter break next week, Wednesday. So there is no e-session. And so there we are with that. This week we are doing and looking at formula mass or molar mass, really the same thing. And we'll do some practice together, and then hopefully send you on your way with some confidence on how to do this. So I am going to just first go through what is on tap for this week, what you have as resources for you, and then you can decide what you would like to do from there. So let's just get on into this. We are at week 15, formula masses. Our big ICANS is to calculate formula mass, convert between grams and moles with a compound, and then identify types of chemical reactions. That's actually next week, so I'm not really sure why oops. I'm just going to edit that really quick because that should not be in there. My mistake. Dink, dink. Okay, yay, our ICANs are correct. We can calculate formula mass. We can convert between grams and moles with a compound. And so one of the first things that you guys have here is we have me going through, again, what is the mole, Avogadro's number, mole, dozen, etc. We have some student notes here for you guys to be utilizing on page 27. I gave you guys some pages here with some extra examples about how to find formula mass and molar mass of compounds. I also showed you how I set my notebook up. I actually wrote out my notes this time. I do like to use different colors. And then we have practice. We have practice calculating formula mass and then converting. And then we do have our summative here. And this summative is going to be graded by Blackboard if you can get it in by the 22nd. Otherwise, Mr. Wozniak and I will grade your attempts. And this is just performing those calculations and letting us know that you are able to do that, because if you cannot do that, then it's going to be increasingly difficult when we come back from winter break and start looking at reactions. So I'm first just going to stop here for a second and ask if I'm first just going to stop and ask if you guys have any clarifying questions about not about the lesson itself, because I've already seen some of those, but anything about what you need to do for this week, or if you have any clarifying questions about the schedule of when things are due for this week. Okay, so what I'm going to ask for you guys to do is, if you feel fairly confident in what's going on in chemistry today, then Mr. Wozniak and I wish you the happiest of holidays, and we will see you back in 2021 on January 6th for our first e-session of the new year. If you feel like you would like to stay and go through the lesson, then I ask for you to open up your notebook to page 27, and I'm going to put a minute on my timer and get ready to go over things. You will also need your periodic table. Sorry. All right, let's get started. So formula mass and molar mass, pretty much the same thing. We are calculating the mass of a compound. If you guys could I would really appreciate if you would let me go through the lesson, and then I can probably will be answering your questions instead of popping a question in, and that kind of disrupts my flow of how I wanted to go through things. That would be much appreciated. Thank you. Formula mass, molar mass, basically this is the mass of a compound, and we are going to first go through and practice doing that. It's fairly easy. You are literally just going to be adding up the atomic masses of whatever is in that compound to get yourself a formula mass or a molar mass. Keep in mind that when we, just a reminder, that when we take a atomic mass off of the periodic table, that we are talking about grams per mole as our unit. And so that will be the same for a formula mass or a molar mass. So this is going to equal grams per mole. Okay, so I know we had talked about that in earlier sessions, and I just wanted to do that as a reminder. So let's dive in and do the easiest of the easy, and we'll do NaCl. Okay, so this compound right here, to get the formula mass, we are going to add up and look at what sodium is and what chlorine is. Okay, so sodium has an atomic mass, I think, of like 22.9, and I would round that up to 23. And chlorine, I believe, is 35 point something, 35.4. So you can round that down to and just keep it at 35. We can do some rounding in order to make our formula masses less complicated. If you were to decide to go on to an AP chemistry course, then we would not be rounding quite as much. We would be using more of a concept called significant figures. But in this case, we will round. And so you're simply going to add them up. We have 1 sodium, we have 1 chlorine. So if I were to add these two up, I would get 58 grams per mole. Now I'm going to stop talking for a second, and I'm just going to allow you guys to write this down, take any notes that you need. At this time, if you have a clarifying question that you would like to ask because you don't understand where something came from, this would be a perfect time to do that. That is the entire process for finding formula mass. We're going to go on to a little bit of a trickier one just so that you guys start to, so you learn how to use the subscripts, but that is the process. It's pretty straightforward, yes. Okay, so let's do another example, and this time I want to bring in a formula or a compound that has a subscript to it. So for example, let's do our favorite thing to drink in the entire world, H2O. Okay, so let's find the formula mass, because in this one we have a 1-to-1. There's one of these and one of these, so we simply just add them up. Awesome. But that's not every compound. Some compounds have some some trickier or more than one of each element. So let's go through and do this one. So in this case, this looks like a D, but it's really an O. So hydrogen is 1.00 something. It's like 7 or 8. So I'm just going to say 1.0, but I have 2 of them. So I need to multiply that by 2. I'll just put that in large parentheses. So I need to say 1 times 2. And then oxygen here is 16. I think it is 16 point, it's 15.99. So that's what it was. So it's 16 if we round it up. And I only have one of those, so I have 16.0 here, if I can do this. And so if I take 1 times 2, I have 2, and 2 plus 16 gives me a total of 18 grams per mole. Okay? So there is one where we're starting to use, and we had to use the subscript. So again, I'm going to pause for about 10 to 15 seconds, allowing you guys to look at that and ask any questions about this example that seem to trip you up or that doesn't make sense to you right away. Yep, that is correct. So you just remember that that 2 is associated with that hydrogen or that element, then yes. Okay, so now we're going to go on to another example, and this example is going to have one of our favorite things in the whole entire world, and that's those polyatomic ions. Remember, we had talked about polyatomic ions, and with polyatomic ions, we have a list of those. You should have either printed that list or hand wrote that list so you can refer to it. But these are compounds that act like elements, but they're actually compounds. And so we do have to take formula masses or calculate formula masses of compounds that include a polyatomic ion. So you're like, all right, let's go for it. So my example is going to be Na, NO3, okay? And so we're going to look at these, right, this one right here. So when we take it again, we're going to use the exact same process. So sodium right here, we already looked up. We saw that that was 23. And I know that I only have one of those. But now I'm going to look at this polyatomic ion here, and I'm going to take each individual element. So I have to look up what nitrogen is, and I believe nitrogen is 14. So I'm going to just make sure nitrogen is 14. Yep, 14.00. Plus, now we already know that oxygen is 16, but I have 3 of them. So in this case, I'm going to take 3 times 16. And that's going to give me my formula mass. So I'm going to say 23 plus 14 plus 3 times 16. Okay, and hopefully you come up with 85 grams per mole. So again, I'm going to pause for about 10 to 15 seconds, allowing you guys to process what we just did here. So we've gone from a simple formula of 1-to-1 to one that has some subscripts in it to one that is using a polyatomic ion. So like simple to more complicated. Good. I'm glad this is making a lot of sense. What confuses a lot of times is like chemistry likes to have the same term but means the same thing. So formula mass, molar mass, those are interchangeably used generally, and that means the same thing. It means the mass of a compound. And just remember that we're talking about grams per mole. It's really important that you remember that, because when we get into the next stage of this and we start converting, we have to know that this is grams per mole. All right, would you guys like to do a example on your own, or do you guys feel fairly confident and you want to move on to the converting part? All right, so I've gotten 2 votes. It doesn't matter as long as you understand that you are multiplying. Like I could go like this too. You just have to make sure that this 3 or this number, whatever this subscript is being multiplied by the mass of that element and not multiplying the entire mass. Does that make sense? Okay. All right, so at this time, I'm just going to clear my board and we will get into converting. Okay, we're going to go from, again, simple to the more complicated version. I'm going to switch to purple. All right, here we go. So remember I told you that our formula mass or our atomic mass or our molar mass, all of these things are going to have the unit of grams per mole. Okay. So we have to keep that in mind. And in chemistry, we are going to be asked to convert our units from grams to a mole to possibly molecules. Okay. And so we know that when we do a formula mass, we are doing grams per mole. And then we just have to remember that that Nicholas even brought this up, that we have Avogadro's number, or that mole, but this is 6.02 times 10 to the 23rd. And this is when we are going to be converting to molecules. Okay, so this is a key number to remember. Also, what is a key thing to remember with this is a little while back, we worked with our, either if you're working with your calculators or your calculators on your phone or possibly a computer calculator, we worked on being able to take scientific notation and input that into our calculators in an appropriate manner so that we get the right answer. So we also have to call upon that. Remember, chemistry builds on itself. So what we've learned a couple weeks ago is going to rear its ugly head again if you didn't understand it a couple weeks later. Now we're getting into the section of chemistry where we're going to start to really put all the pieces that we learned together in big chemical sentences and big calculations. So keep that in mind, okay? So anytime we get like a converting, that means that we are, let's say we're in a virtual lab, or we are in, or we're in a face-to-face lab, or we're faced with a word problem, especially if you were going on to AP chemistry. And so my first example to you guys is going to be that I have 4.96 grams of NaCl, sodium chloride, and I want to know how many moles that is. All right. So the first thing that we're going to do is remember that this is, we need our formula mass for this. So the first thing we need to find is the formula mass or the molar mass of NaCl. Now, if you guys already look back at your notes, we did do this, but we'll go through it again. So again, we're going to calculate the formula mass. We know that this is 23. This is 35. And so we get a number of 58 grams per mole. All right. The second thing we do is, this is how I set up conversions. This makes a lot of sense in my head. When you see this way, if you notice a different way that works for you, by all means use it. Again, we are going to think about our math skills, and we're going to think about strategies we use in math. And sometimes you use the way your teacher says, and sometimes you don't use the way your teacher said because you found a different way. So the first thing we're going to do is I'm going to draw a line, and I'm going to put my starting number that I was given in the problem. So I'm going to put my 4.96 grams. I also want to point out that it is imperative that you carry your units with your numbers so that you understand what units go with what numbers and what you need to do with them, okay? When you are converting, the object is to cancel out this unit or this grams here. So I like to go like this, and on this bottom here, I'm going to put grams, all right? Because then when you multiply, or I mean, when you divide, you will cancel out your unit. Now you're asking what number goes here? Well, the number that goes here is the formula mass. So I have 58 grams for every 1 mole. And so what you're left with is you are left with the unit of mole. And that's exactly what I want because that's what the question is asking of me. And then you're like, okay, well, what the heck do I do with this? So what you would do, and I'm going to change this to black here. So when we read this number, essentially like a number line, I would multiply across. So I would say 4.96 times 1. And then I would divide down. So then I would divide 4.96 times 1 divided by 58. And that is going to give me my answers. So when I do that in my calculator, I'm going to put in I know that 4.96 times 1 is 4.96, and I'm going to divide it by 58, and I'm going to come up with a number of 0.08, we'll go 55. Again, I am going to right now stop talking for the next 15 to 20 seconds to allow you to write this down or finish writing it down and process the 2 steps that I have done. I'm just putting that out there because we are going to venture to this at some point. But right now we're just going from grams to moles. We're not using it for anything yet, just a reminder. All right. At this time, I only saw one clarifying question come through, which is fine. And a great question. Are there any other clarifying questions that come through? Okay, so what I would like to do at this time is I'm going to erase my whiteboard and I'm going to put up a problem for you guys to solve, just to make sure you are fully understanding how to get the answer. Sound good? All right, here we go. So I have I should really get a pen that would really help out a lot. Okay, here we go. So I have 7.56 grams of lithium nitride. How many moles do I have? Okay, so I'm going to put about 45 seconds on my timer. And as the time ticks down, I will start working the problem out and you can see if you are on the right track, okay? All right, go to it. All right. Give me a thumbs up, a smiley face, a Christmas tree if you got it right. Give me one question you have if you got it wrong. I see some thumbs up coming up. I definitely don't see everyone participating that we have in here. All right. So now do you guys think you could do this? Oh, yep. If you get your formula mass wrong, then other things will be wrong. And it's actually a really good point, Jessica, to bring up, because you guys might be thinking like, okay, when Mr. Wozniak and I look at your work, this is why it's so important for you guys to show your work to us when you are submitting formatives and summatives, because if we see that you did this wrong, but then did all the other steps right, we can give you points for those other steps, and then just tell you that you calculated the formula mass wrong. But if you just give us an answer, then that answer is wrong, and then all we have to do, we can't give you any points. Well, for this time it is. Anytime you're going from grams to moles, this top is going to be a 1 mole because it is grams per 1 mole. So this is 35 grams per 1 mole. So if I have 35 grams for every 1 mole. Now my question is, can we go in reverse? Can I give you something in moles and you go to grams? So let's see what that looks like. Let me clear this off. So now let's say that I have 0.890 moles of H2O. And I want to go to grams. Okay, so we're going to do the reverse, kind of. The first thing you're going to do still is you still need that formula mass of your compound. So we have H2O here. And I'm going to have 2 times 1 plus 16, which is going to equal 18 grams for every 1 mole. Okay. The second thing is we're going to set up this the same way. I'm going to have my opening number here that I've been given. So I have 0.890 moles. And the object is to have your unit that you're in cancel out. So that means now I'm going to put moles down here so that it cancels out. And we know that for every 1 mole, I have 18 grams. So the unit that I want to be in is up in this right-hand corner. My unit is going to be grams. And now again, I'm going to read this the same way. I'm going to read across, I'm going to multiply across. So I'm going to say 0.890 times 18 divided by 1. And so when you do that, oops, nope, I don't want to do that. I was like, that doesn't look right. Yeah, so you get 16.02 grams of water. So in this case, Tristan, my 1 mole is not in the upper right-hand corner because I am starting with the unit of moles. So you really have to think through where you're starting and where you're going so that you can put your units in the right spot. And once you have your units in the right spot, you can add your numbers. That's generally how I think of it. Obviously, the more you do these, the faster pace they will become to you. Again, I'm just going to stop for about 10 to 15 seconds and have you think of any because I have 2 hydrogens and the atomic mass of hydrogen is 1. Any other clarifying questions? You are welcome, Jessica. All right. Would you guys like to practice an example problem of this? Or we can get into a more complicated one of going to molecules. All right, so I'm going to clear my board here. Okay, so Jessica, now we're going to use our number 6.02 times 8 to the 23rd, okay? There, our number's going to come into play. So remember, we talked about this number 6.02 times 10 to the 23rd. And this number is going to go with the unit of molecules. Okay? All right. So when we do this, we're going to add to our fun here. We're going to do a full length conversion. So let's say in my example here, I'm going to say that I have let's go 55.1 grams of NaCl, and I want to know how many molecules that is. Okay, so our setup is going to be the same in that we are going to first have to find out what our formula mass is of NaCl. So this case, we have 23, we have 35, and that gives us 58 grams for every 1 mole. Okay, and next second time, the second setup is going to be done the same. We're just going to be adding to it. So we're again going to start with our number here of 55.1 grams. And what we have to do is we're going to first have to go to moles, just like we had done. So for every 1 mole, for every 1 mole, I have 58 grams. So now my grams is going to cancel out. Okay, but now I am going to add on. And so now I know that for every 1 mole, and remember I want moles to cancel out, I have 6.02 times 10 to the 23rd molecules. So again, when I read this across, we're going to read it the same way. So I'm going to say 55.1 times 1 divided by 58 times 6.02 times 10 to the 23rd divided by 1. Now the trick is to put that into your calculator correctly. I personally like to do 2 different steps. So I like to say 55 times 1, 55.1 times 1. So that is 55.1 divided by 58. And I like to hit enter. Okay. And then I like to hit times 6.02 to the 23rd, and then hit enter. And so I get 5.719 times 10 to the 23rd. I'm going to pause for about 35 seconds to allow you to continue to write and process what I just put up there. All right, Nicholas, what I need for you to do is I need for you to give me a section in which you become lost. Because this section right here, let me just grab a different color here. So this section right here that's in purple is what we have just been practicing. So at what point are you confused, or and so give us a question here that we can start to unravel why you're lost. Emily, I do not think you are unintelligent, so please do not speak of yourself that way. It is perfectly fine to be very slow or slow at processing what's going on. I am definitely that way. I have to do several examples before I get it to see the patterns that are evolving. So I'm really happy that you think it's panning out to make sense. Well, you can tell your classmates at your old school to eat it. You got it, Tristan. You just got to really think about where your units go and then what numbers follow with those units, and then you're all set. And you guys, you can, like, you might, one thing that I don't know that I explained awesomely well is that when you are going from grams to molecules, we do have to do moles. And you might be wondering, why did I put 1 mole? How did I know to put 1 mole here and then 6.02 times 10 to the 23rd molecules here? You can think of this as 6.02 times 10 to the 23rd molecules for every 1 mole. Nicholas, I'm almost wondering if you typed in 6.02 times 10 to the 23rd correctly into your calculator, whatever calculator you're using. I'll check mine. .1 divided by 58. I always like to just hit enter, and then I'm going to multiply that by 6.02. Now in my calculator, I have to hit the second button and then the EE button to put in 23. Yeah. Thank you, Mr. Wozniak. I really think that you just put it in your calculator wrong. My biggest question though, Nicholas, is do you understand why the numbers are where they are? And do you understand how we set this problem up? Because if you do those two things, then plunking into your calculator is an easy fix. Okay, great. Do you guys want to try a problem on your own? Okay. Let me clear this out. We'll go back to our fun blue here. So I'm going to say that I have 125 grams of sodium nitrate. And I want to take that and know how many molecules. So I'm going to put a little bit longer on the clock for you. All right, ladies and gentlemen, how are we feeling? There you go, Tristan. Good. There you go, Nicholas. All right. So at this time, that's okay, Emily. So at this time, Mr. Wozniak and I feel like you should have all the tools you need to complete this week 15, remembering that nothing is due really until the 22nd of December. And we wish you the happiest of holidays. however that might look for you and your family this year. And we will see you guys January 6th for our first e-session of the new year. So happy holidays, happy new year. If you are still feeling a bit confused, please stay after the e-session. We can do our best to answer any questions you may still have remaining. Otherwise, bye guys.